Picture this. You're not just visiting space. You're moving and swapping your Earth address for a cosmic one. Weeks, months, maybe even years among the stars. What comes to mind first? Is it the awe-inspiring
The
views?
feeling of weightlessness.
Or perhaps the challenges of living in such an extreme environment?
It's fascinating how often people focus on the obvious challenges like oxygen and temperature.
Right.
Those are crucial, of course,
Of
but
course.
there's so many other things we take for granted on Earth that become major obstacles in space.
Okay, give us an example. What's something that surprised you when you first started learning about this?
The impact of microgravity on the human body is truly remarkable.
Yeah.
Did you know astronauts can lose bone density at a rate of 1 to 2% every month in space?
That's shocking.
It's essentially accelerated osteoporosis.
Why does that happen? Is it just because they're floating around all the time?
It's more complex than that. On Earth, our bones and muscles are constantly working against gravity,
Right.
which keeps them strong.
Mm-hmm.
But in a microgravity environment, that constant stress is gone.
Oh, I see.
Imagine carrying a heavy backpack all the time.
Yeah.
And then suddenly taking it off, your body would start to adapt to that lighter load.
So their bones and muscles basically start to think, hey, we don't need to be this strong anymore.
Exactly.
But it's not just about getting weaker, right? There are other weird side effects too.
Exactly. Fluid redistribution is a big one.
Yeah?
Without gravity pulling fluids downwards, astronauts experience puffy faces, stuffy noses, and even vision problems. It's officially called Spaceflight-Associated Neuroocular Syndrome, or SANS, and it's a serious concern for long-duration missions.
SANS. That sounds intense. I had no idea. It makes you realize how perfectly adapted we are to Earth's gravity. What about radiation? We're protected by the atmosphere down here, but out in space, it's a whole different story.
Radiation exposure is a major challenge. Astronauts are bombarded with much higher levels of radiation in space, which increases their risk of cancer and other health issues.
Right.
This is why radiation shielding is such a crucial area of research.
So we've got weakening bones, muscle atrophy, strange side effects, and radiation risks. It paints a pretty daunting picture of the physical challenges alone. But what about the psychological and social aspects of living in space? That must be a whole other layer of complexity.
Absolutely. Imagine being confined to a small spacecraft with the same people for months on end, far from family and friends with limited communication with Earth. That's the reality of isolation and confinement in space.
That sounds incredibly tough.
Yeah.
Even with the best roommates, I'd need a break eventually. How do astronauts cope with that level of isolation and the potential for conflict?
Astronaut selection and training are incredibly rigorous.
Oh, wow.
They undergo extensive psychological evaluations and participate in simulations that mimic the stresses of long-duration spaceflight.
Yeah.
Teamwork, communication, and conflict resolution skills are paramount.
It makes sense. You'd need a really strong team dynamic to thrive in that kind of environment.
Yeah.
But beyond the close quarters and isolation, there's also the strangeness of the space environment itself. What kind of impact does that have?
The disruption to circadian rhythms is a major challenge. On the International Space Station, astronauts experience 16 sunrises and sunsets every 24 hours.
Whoa.
Imagine trying to adjust to that.
That's mind-boggling. How do they even sleep with that going on? Do they just rely on blackout curtains and willpower?
It's a combination of things.
Okay.
They use controlled lighting to mimic a more Earth-like day-night cycle.
Okay.
Sometimes they use sleep aids as well. But maintaining a healthy sleep-wake cycle is a constant battle in space.
So we've covered the physical and psychological hurdles, but keeping humans alive and functioning in space can't be easy from a technical standpoint either.
Right.
What are some of the biggest engineering challenges involved?
Life support systems are absolutely critical.
Right.
We're talking about creating a miniature Earth within a spacecraft, managing air, water, and food, all the essentials for survival in a closed system. And these systems have to be incredibly reliable, as any malfunction could have dire consequences.
It sounds incredibly complex. Can you give us a glimpse into how these life support systems actually work? What are some of the innovative solutions they've come up with?
One of the most remarkable things is the way they generate oxygen. They split water molecules using electrolysis to create breathable oxygen, which is essential for survival. And to conserve resources, they've developed sophisticated systems for recycling wastewater.
Recycling wastewater? Is that what I think
Yes, they recycle urine into drinking water. It might sound unappealing, but the technology is incredibly advanced. The water goes through a rigorous purification process, making it completely safe and drinkable. It's a testament to the ingenuity of engineers and the need for sustainable solutions in space.
Okay, I have to admit, that's impressive. It's incredible how they're turning what we consider waste to valuable resources. But what about power? How do they keep the lights on and all those systems running? Is it all solar panels?
Solar panels are a primary source of energy, but they have limitations. Think about dust storms on Mars, which could block sunlight for extended periods or long lunar nights. Efficient energy storage and backup systems are crucial for maintaining a stable power supply.
Right, you can't just call an electrician if the power goes out on a space station. And speaking of things, you can't easily fix waste disposal, must be another major challenge. You can't just toss it out the airlock, can you?
You're right. Managing waste in a closed environment is crucial to prevent contamination and ensure long-term sustainability. Scientists are developing advanced waste-to-resource technologies to address this challenge.
So it's like one giant puzzle, figuring out how to make everything work seamlessly in such a harsh environment. But with all these obstacles, is long-term space living even feasible? What gives you hope that we can overcome these hurdles?
We're constantly learning from the International Space Station.
Yeah,
And the pace of technological innovation is accelerating. There are some truly groundbreaking solutions on the horizon.
that's encouraging. Can you give us a sneak peek at what's coming next in the world of space habitation? What kind of advancements are you most excited about?
There are some fascinating developments in exercise equipment designed to combat bone and muscle loss.
Okay.
And researchers are exploring things like water walls for radiation shielding.
Water walls.
Yeah.
That sounds intriguing. Can you elaborate on that?
Imagine surrounding a habitat module with a thick layer of water. This water barrier would act as a shield absorbing harmful radiation and protecting the astronauts inside. It's a simple concept, but surprisingly effective.
That's amazing. Using water as a natural shield. What other creative solutions are they exploring?
Well, they're also working on ways to grow food in space, not just basic lettuce, but a variety of crops to supplement their diet.
So space farming is becoming a reality. What are the challenges involved in growing food in such a foreign environment?
It's not easy, but they're making progress using methods like hydroponics and aeroponics.
I've heard those terms before, but can you refresh my memory on what they mean?
Of course, hydroponics involves growing plants in a nutrient-rich water solution,
Okay.
while aeroponics suspends plants in the air and sprays their roots with a nutrient mist. Both methods eliminate the need for soil, which is a huge advantage in space.
So no hauling bags of soil up to space.
Right.
That makes a lot of sense. What kinds of crops are they able to grow using these methods?
On the ISS, they've successfully grown lettuce radishes and even some flowering plants.
Wow.
It's still early days, but the goal is to expand the variety of crops and eventually create self-sustaining food systems for long-duration missions.
Imagine having fresh vegetables on a mission to Mars.
Right.
That would be a game changer, both for nutrition and morale.
Absolutely. It would be a huge step towards creating a more self-sufficient and sustainable presence in space.
This is all incredibly fascinating, but we've only scratched the surface of this complex topic. I'm eager to learn more about the cutting-edge innovations that are shaping the future of space habitation.
I'm happy to share more insights. There are some truly remarkable developments in the works.
Great. We'll continue this fascinating discussion in part 2 of our deep dive, where we'll explore those groundbreaking solutions in more detail. Stay tuned.
Welcome back to Cosmos in a Pod. It's incredible to think about the strides we're making in space habitation, turning what was once science fiction into reality.
It really is mind-blowing. In the last part, we talked about some of the major hurdles humans face when living in space. Now I'm curious to learn more about the ingenious solutions being developed to overcome those challenges. What are some of the most exciting advancements you're seeing in this field?
One area that's particularly fascinating is the development of advanced exercise equipment designed specifically for microgravity environments.
That makes sense considering how much bone and muscle loss astronauts experience.
Yeah.
So what kind of futuristic gym equipment are we talking about? Are they running on treadmills that float?
Not quite floating treadmills, but they do have specialized treadmills on the International Space Station. Astronauts have to wear harnesses and bungee cords to simulate the feeling of running against gravity. But one of the most innovative pieces of equipment is the Advanced Resistive Exercise Device, or AED.
AED. That sounds intense. What does it do?
It's essentially a weightlifting system for space. It uses vacuum cylinders to create resistance, allowing astronauts to perform squats, deadlifts, and bench presses, even in zero gravity. These exercises are essential for maintaining muscle mass and bone density.
So they can still pump iron even without gravity's pull? That's incredible. It's amazing how engineers find ways to adapt to the unique challenges of space. But what about radiation, one of the biggest threats to long-term space travel? Are there any promising solutions in the works to protect astronauts from harmful radiation?
Radiation shielding is a critical area of research. One of the most interesting concepts is the use of water walls, which we touched on earlier.
Right, using water as a shield. But how does that actually work? It seems counterintuitive that something as basic as water could protect against something as dangerous as radiation.
It all comes down to the hydrogen atoms in water. Hydrogen is incredibly effective at absorbing radiation, particularly the high-energy particles found in space. So surrounding a habitat module with a thick layer of water would significantly reduce the amount of radiation that reaches the astronauts inside.
That's so clever. Harnessing the power of a simple element like water to create a protective barrier. Are there any other radiation shielding ideas being explored?
Researchers are also investigating the use of regolith. The loose rock and dust found on the surface of the Moon and Mars. Regolith contains elements that can help absorb radiation, and it's readily available on these celestial bodies. They're looking at ways to incorporate regolith into building materials, or even create shielding structures around habitats.
That's fascinating. Using the materials already present in space to protect ourselves. It's like living off the land, but on a cosmic scale. But speaking of living off the land, let's talk about food. We briefly discussed space farming earlier, but I'd love to delve deeper. How realistic is it to grow a sustainable food supply in space? And what are the biggest hurdles they face?
Growing food in space is no longer just a futuristic dream. It's becoming a reality. The International Space Station has already had success growing lettuce and other leafy greens, and researchers are constantly experimenting with new crops and techniques.
It's incredible to think about astronauts harvesting fresh produce in space. But how do they make it work? What are the key methods they use?
Hydroponics and aeroponics are two of the most promising techniques for space farming.
Right, we talked about those briefly before. Can you remind us how those systems work and why they're so advantageous in space?
Absolutely. Hydroponics involves growing plants in a nutrient-rich water solution, while aeroponics suspends the plants in the air and mists their roots with a nutrient solution. Both methods eliminate the need for soil, which is bulky, heavy, and difficult to transport to space.
So it's all about maximizing efficiency and minimizing waste, which makes perfect sense in a closed environment like a spacecraft. But can they grow anything beyond leafy greens? What about more substantial crops like fruits or vegetables?
That's the goal. Scientists are experimenting with growing a wider variety of crops, including dwarf fruit trees, tomatoes, peppers, and even strawberries. The challenge is to create closed-loop systems that efficiently recycle nutrients and water, ensuring long-term sustainability.
It sounds like a delicate balancing act, creating a miniature ecosystem within a spacecraft. But are there any unexpected benefits to growing food in space?
One intriguing discovery is that plants grown in space might actually be more nutritious than their Earth-grown counterparts. Research suggests that microgravity can enhance the production of antioxidants and other beneficial compounds in plants.
That's fascinating.
Yeah.
So space-grown food could be a superfood. Who knew? But all this talk about space farming and innovative technologies makes me wonder about the mental and emotional well-being of astronauts. Living in such an isolated and extreme environment must take a toll. Are there any advancements focused on supporting their mental health?
Absolutely. Mental health is a top priority for long-duration missions. One area of focus is developing virtual reality tools for relaxation and recreation.
Virtual reality in space. That sounds futuristic. How does that work?
Imagine an astronaut putting on a VR headset and being transported to a peaceful beach, a lush forest, or even their own living room back on Earth. VR can provide immersive experiences that help combat feelings of isolation, homesickness, and stress.
That's amazing. A virtual escape from the confines of a spacecraft. It sounds incredibly therapeutic. Are there any other innovations in the works to address the psychological challenges of space travel?
Another area of research is focused on creating artificial gravity environments.
Wait, artificial gravity, is that even possible? It sounds like something straight out of a science fiction movie.
It might sound far-fetched, but there are several concepts being explored. One idea involves rotating a spacecraft or habitat module to create centrifugal force that mimics the effects of gravity.
So like a giant spinning space station? That's mind-blowing. But how would they make that work without making everyone feel dizzy and nauseous?
That's one of the key challenges. They would need to find the right balance between rotation speed and the size of the habitat module to create a comfortable level of artificial gravity without causing motion sickness.
It sounds like a complex engineering feat. But if they could pull it off, wouldn't artificial gravity solve a lot of the problems associated with living in space?
It could potentially mitigate many of the negative effects of microgravity, from bone and muscle loss to fluid shifts and even psychological stress. It would be a game changer for long-duration missions.
Wow, it's incredible to think about all the possibilities that open up when we start to manipulate gravity itself. It really highlights the ingenuity and determination of scientists and engineers in this field. But with all these groundbreaking advancements, what are some of the remaining challenges that keep you up at night?
Well, one of the biggest concerns is the long-term impact of reduced gravity and radiation exposure on the human body. We have a lot more research to do to fully understand the risks and develop effective countermeasures.
That makes sense. It's a whole new frontier of medicine, figuring out how to keep humans healthy in such an alien environment.
Exactly. And another challenge is the sheer complexity of building and maintaining self-sustaining habitats in space. We're talking about creating closed-loop life support systems, managing resources, and dealing with unforeseen problems far from Earth. It's a monumental undertaking.
It sounds like a delicate dance between pushing the boundaries of technology and ensuring the safety and well-being of the astronauts. But despite these challenges, it seems like we're making incredible progress toward making long-term space habitation a reality.
We are. And it's not just about the technology, it's about the human spirit of exploration, the drive to push beyond our limits and expand our understanding of the universe and our place within it.
It's inspiring to think about the collaborative efforts of so many brilliant minds working together to achieve this common goal. And it makes me wonder about the bigger picture, the philosophical implications of venturing beyond Earth. Why are we so driven to leave our home planet and establish a presence among the stars?
That's a profound question, and one we'll explore further in the final part of our deep dive. We'll delve into the motivations behind space exploration, the potential benefits for humanity, and the ethical considerations we face as we expand our reach into the cosmos.
Welcome back to Cosmos in a Pod for the final part of our deep dive into this extraordinary world of long-term space habitation.
It's been quite a journey.
It really have.
Exploring the nuts and bolts of living in space,
Yeah.
the challenges, the innovations, and the sheer audacity of it all.
We've covered a lot of ground, from the physical and psychological hurdles to the technological marvels that are making space habitation a tangible possibility. But amidst all the technical details and scientific breakthroughs, there's a bigger question that lingers.
Why?
Why? Why are we so driven to venture beyond Earth and establish a presence among the stars?
That's the question that keeps echoing in my mind. What is it about space exploration that captures our imagination and fuels our ambition? Is it simply the human desire for adventure and discovery?
It's certainly part of it.
Yeah.
Humans are explorers by nature. We have an innate curiosity to push boundaries,
Right.
to seek out the unknown, to understand our place in the grand scheme of things. Space, with its vastness and mystery, is the ultimate frontier, beckoning us to unravel its secrets.
It's like that age-old urge to explore uncharted territories,
Right.
to see what lies beyond the horizon. But there must be more to it than just wanderlust. What are some of the practical reasons for investing in space exploration and habitation?
The practical benefits are numerous. Space exploration drives technological innovation, leading to advancements that benefit us here on Earth.
Absolutely.
Think about satellite technology, communication systems, GPS navigation, and even medical imaging techniques. All of these stem from space research.
It's amazing how those spin-offs from space technology
I know, it's crazy.
have become so seamlessly integrated into our daily lives, we rarely stop to think about the origins of these innovations.
And then there are the resources.
Right.
Asteroids, for example, contain vast amounts of valuable minerals and metals that could potentially be mined and utilized to address resource scarcity on Earth.
Absolutely.
So it's not just about expanding our knowledge, but also about securing our future by tapping into the resources available in space. But some argue that those resources should be left untouched, that we should focus on solving problems here on Earth before venturing into space. What's your perspective on that?
It's a valid concern. We certainly have pressing issues to address here on Earth. But I believe that space exploration and tackling earthly challenges are not mutually exclusive. In fact, they can be complementary. Investing in space technology often leads to innovations that can be applied to solving problems here at home.
Like the advancements in renewable energy technologies or water purification systems, for instance.
Exactly. And there's another crucial aspect to consider: the long-term survival of our species. Earth is a finite resource, and we are facing unprecedented challenges, from climate change to resource depletion. Establishing a presence on other planets, while a daunting task, could serve as a safeguard for humanity's future.
It's a sobering thought, but a realistic one.
Right.
It's like having a backup plan for the entire human race. But even with all the potential benefits, venturing into space raises ethical questions as well.
Absolutely.
Who has the right to claim resources on other planets? How do we ensure responsible exploration and avoid contaminating other worlds?
You've hit on some of the most critical considerations. As we venture further into space, we need to establish clear ethical guidelines and international collaborations to ensure responsible and sustainable exploration. We have a responsibility to be good stewards of the cosmos, respecting the potential for life on other planets, and preserving the pristine environments we encounter.
It's a delicate balance
Yeah,
between exploration and preservation, ambition and responsibility.
right.
But I have to admit, despite the challenges and ethical dilemmas, the allure of space exploration is undeniable. There's something profoundly inspiring about pushing the boundaries of human ingenuity and venturing into the unknown.
It's a testament to our collective spirit of adventure and our unwavering desire to understand our place in the universe. And who knows what wonders await us as we continue to explore.
Yeah.
We might uncover evidence of past or present life on other planets,
Right.
discover new laws of physics, or perhaps even encounter other intelligent civilizations.
It's both humbling and exhilarating to contemplate the possibilities.
It is.
And it makes me realize that space exploration is not just about scientific discovery. It's about expanding our consciousness, pushing the limits of human potential, and perhaps even redefining what it means to be human.
Beautifully said. And I believe that each step we take into the cosmos is a step towards a deeper understanding of ourselves, our place in the universe, and the infinite possibilities that lie ahead.
Well, this deep dive into the world of long-term space habitation has been truly enlightening. We've covered a vast territory from the technical intricacies of life support systems to the profound philosophical implications of humanity's journey into the cosmos. I'm filled with a sense of awe and wonder, and I hope our listeners are too.
It's been an absolute pleasure sharing this exploration with you and our listeners. I hope it has sparked a sense of curiosity and a desire to learn more about this incredible frontier.
And to our listeners, thank you for joining us on this cosmic adventure. Be sure to subscribe to Cosmos in a Pod and check out our YouTube channel for more explorations of the wonders of space. We'll see you next time.